Hi, today I was working on a project that I'm working on, which is huge and has a lot of files, and it's all mixed up with many components. It has maybe around 200,000 objects in the scene. So I was really struggling with trying to find specific components that I didn't remember what the names were, and it was quite hard because normally what you do is if you want to find which objects in the scene have a specific component you already have, you can select the not a native component, but if you want to find an object that has a component that you made, a script, it won't, unless you find the script and then you right click and you find references in scene. This one, find reference in scene. It's quite slow. Finding objects in the scene is can be very slow, but you have to know which is the script or which is the component. So I thought, why not make a tool to find which objects contain a given, the part of the name is a given string, like a given name. So you can find all the components and all the objects in the scene that have that name or contain that name, which makes it useful to find specific things that you don't remember what the names were and stuff like that. So let's build a small tool to do this, and I think it would be cool to try to do this. So I did this today, and I wanted to show you guys what I did, how I did it. So let's start from the beginning. What I want to do, I want to build a small window like this one, right? But first, what I have to do is create a script, and the script is an editor script. That means that I have to put it inside a folder that is called editor. That's really important. Anything you do for the editor, a menu item that adds stuff up in here, or maybe a window or something like that, you have to create an editor folder. That way, when you make the build or you build the project, it won't take anything that is inside an editor folder. That's important. Otherwise, the build will fail. So let's open the editor folder and create a new script here. The script will be called, find component in scene, for example. I normally want to change this to, reduce the zoom in here so I can see the names of the files right here. That's because I work on code generally. I never work with images or materials and stuff like that. Generally work with code. So I prefer to see the whole name, So, okay, let's open that file. What it creates is a basic file, which is a mono behavior. So let's change this because it's not going to be a component. So you can delete everything inside, delete all the lines that are gray, which you don't need, but maybe we have to add them afterwards. So let's start with the name of the class, and this is what I'm doing is an editor window. So let's call it editor window. Now we'll start having a problem. Editor window is inside a namespace that is called Unity Editor, which is here. Using Unity Editor, Visual Studio helps you with these things, so it will add itself, add this when you do that. So, okay. So editor window, and what's the first thing we got to do is, a way to open this editor window, and it's a static function. So that means that you can create the window even if it doesn't exist, still exists. Sorry about my English, I'm not native speaker, so sometimes I speak a little weird, sorry about that. So, okay, init, and what we're gonna do, what are we gonna do here? Inside here, we're gonna open the window and show it, okay? So, inside the init, we have to make this a function that is called when you click a menu item. So if you go to Unity, you want to add some kind of menu up here that opens up the window. So let's create a new menu here with, I don't know, my name or tools or something like that, menu item. And then let's say tools, find component in scene. That's fine. So let's save it and then let's open Unity, let it compile, and we should be, you know, we should see, that's it. Tools, find component in scene. That's the tool. So that was very easy. If we click here, nothing happens. So what we're gonna do here is create an instance of this class. So what this does is only create and add the menu item. But here, since it is static, we have to create an instance of the scene, of the window, sorry. So let's do that. Let's add the name here, window, and then get window, and the same name in here. This will try to find the window opened in the scene. If it doesn't get the window, I don't really know how this works. What I do is find get window for Unity in Google, and what I did find was that, you know, I never remember everything I do, so I need to find what it is. So get window returns the first editor window of type T, the type passed, which is currently on the screen. If there's none, creates and show a new window. So this will create the window if it doesn't exist. That's enough for us. So let's show it, right? So window, show. Otherwise it doesn't show up. Let's see how it works. Wait for it to compile and open it up. Fine. So there's a window with the name of the window in here, the name of the item here. Fine. So that's enough. Let's also set the size, at least the max, not the minimum size, right? Min size. Windows have a lot of parameters that we can set. Oops. So the size is a vector 2, and we can set it right here. So new vector 2, which is the width and height. So let's set it like 300 and 200F, the float. Okay, we don't need to see that, so that's okay. Now, let's write the next function. The next function should be what's shown on the GUI, on the inside the window. So that's done inside a onGUI or GUI. I don't know if GUI is said in English, but well, I'll say GUI. Sorry about that if it's wrong. So void onGUI. That's it. That's the function that lets us define what's inside the window. So the first thing we need to do is create a field where we can add, like this one, where we can add the text we want to find. We need to find every component that contains that text. Anything you need to add to an interface, you need to do it through editor GUI layout. And we have several fields in here. We need to add a text field. And what does go here? Well, this is the text that goes inside. what's the text? Well, at the beginning we have an empty text. And what this does is returns a string. So you input a string and it returns a string. Text. So whatever is changed in here, it will be stored in here. But what if we create this variable in here? Well, the problem here is that onGUI is called all the time, and this variable will be created all the time. But we don't want that. We want the text to stay all the time. So we need to create a variable outside the class. Let's call it text. It's not a good name, but well, we have to input the text in here. So the text will be written in here, and then when you change it, it will be stored here again. So it will be permanent. Anything you write in here will be stored in the class, in the window, unless you close the window. If you close the window, then it will be gone. So when do we want the text to be set up like an empty text? Well, there's a function that's called on enable. On enable is called whenever you touch the window, but you specifically when you open the window up. Sometimes there, for example, the components, if you select them, then it will be called on enable for the components. But for Windows, it will be called whenever you open it up or you create it. So that's awesome for us because we can set the text in here and it will be an empty text, right? An empty string. Okay, so we have a permanent text that will stay all the time when the GUI is drawn, which happens a lot of times. So let's see if it works. Let's open it up. There you have it. The text field. Hello. And if you get out, it's repainted all the time and it doesn't delete the text. But what happens if I close it and I open it again? The text is gone. Let's attach this window here and then write hi, leave and go back. So on enable is not called when you select the window, but only when it's closed, right? So well, I don't know if you like this option, but well, you can change it if you want. But I like it this way, so the text stays in there, which is great. So now that we have the text, we can use the text for many things. We shouldn't be trying to find the components all the time when you change the text. That would be crazy because it's quite a slow operation. Finding text, breaking strings, putting strings together, every operation with strings is the slowest thing you can do, and it's not a good idea. In fact, this tool shouldn't be slow. I tested it in my project, which is huge, and it works really, really fast. So that's why I'm doing this for you. But anyway, we shouldn't be doing all the time, right? So we should add a button here to make it happen. So we have the text field, and then we have to add a button. But the buttons always go with an if. It's GUI layout. It's not editor GUI layout. I never understood that, but that's, it's in here. Buttons are in GUI layout class. So let's put a find text in here. This button will, if you click it, it will execute the code inside the if. So what should happen? Well, we have a list of things that were found. So we have to create the list of things that were found. What things are those? Well, I think it should be a game object, because that way you can store all the game objects that have the components you're looking for, and you can then I don't know, add a button at the end to select the object in the scene, which would be really, really handy, because when you find a list of objects, obviously you want to find them in the scene, right? So let's have a list, like a permanent list here in the class. List is not available right now because we deleted some class. I'm going to show you now. Found objects. Found objects. List is not available because you need to add using system collections generic, which I deleted at the beginning of the video, but that's okay. So found objects is a list. It restarts the text and also should restart the list. So clear the list if there's something in there stored. I don't want things to pile up, you know. So let's clear the list there. And then we have to create the list right here. So let's do a new list game object. Okay, also when we are clicking find, what should happen is that the list is cleared again. So let's clear the list. The first thing that should be done is clearing the list. That way we can start again from the beginning. So we clear the list, and then we need to find, first we need to run a for, like a loop, over all the objects in the scene, all of them. And then for each object we need to get all the components in each object and see if their name matches our text. I want to test the name of the objects too, so it gives you the objects with given name or the components with a given name. I don't know, it's my choice. So what I chose to do, and it works really, really well. So we clear the list, and then we find all objects, and then for each object find all components. How do you find all objects? Well, there's several ways. I tried to find how to do that, but the easiest way, I think, is to find all objects of type game object, right, in the scene. So let's store, the function is find objects of type. That will find objects in the scene. And the type, which is game object, that returns a list of objects. Game object, list. Static list. So game object list, that will return the list of objects in the scene. So for each object in list, do something. What should we do? Well, we need to see if the object contains the text. That was the first thing I wanted to do. So what's the name of the object? It is object.name, right? That's a string, so we can call contains. And what should we find in the text, in the name? Text, right? That text is the one that is currently in the text field while we click find. So contains, it's a Boolean. So if the given object name gives us that it found the name, found the text in the name, we want it, right? So we don't even need to find the components. We already have the object. So found objects, add the object, and then we should just skip the rest of the steps, right? We already have the object, so continue. That will take the next object in the list, right? If we already have, if we found that the name doesn't match, we need to see all the components. How do you find all the components in an object, in a game object? Well, that's object dot get components, and what is the type of the company we're trying to find? We don't know. We want to find all components, so it should be components or component. The type is a generic one. I know, this is very, very slow, and this is all a very, very slow process, and I know, you know, maybe if the scene is too big and there's too many objects and too many components, maybe this is too slow. So this should be done maybe using jobs or using something that doesn't use the main thread, because we can, you know, the main thread, which is the one that renders the editor, should be free to let you click on cancel or have some kind of a canceling action in case that takes too long. But well, this is a very easy and small tool, and I used it in my scene was like 200,000 objects, and it worked like in less than a second. So that's enough for me, you know. So okay, get all the components. That returns a component list, comps, and for each component, by the way, if you don't know how to do this fast, I've done it before. If you are writing something in Visual Studio and you get to this kind of icon, which is a box with the dots in the bottom, that means that is an auto filler or it's automatic. So if you click tab, the tab key on the keyboard twice, it will create the whole thing for you. So that's really handy. And if you click tab, you can change the stuff, and it's saved. That happens with 4 and many other automatic actions. So comp in comps, fine. For each component found, what do we need to do? We need to see the name of the component. The problem is the name of the component is not comp.name, which is available, but the name of the component is the name of the object that it is attached to. So it doesn't work. Using comp name will give me the object name, right? But I found how to do that, which is get type. Get type will return the type of the component, which is a system type. But if you click dot, if you write dot, it will give you the name itself, the name of the component. I know it's quite weird, but it does work. So let's use this. Okay, so get type returns the type of the component, and then the name of the type, which is the name of the component, the original name of the component. So this is a string, so we do contains again, like the previous example. And then this is an if, because this returns a boolean, like the case before this one. If it's contained, then the name of the component is good for us, and we can store the object again in the list, because the object that contains that component will be the thing that we want to store. So found objects, add object. Which is the object that we add? Well, we add the original object, right? The object that contains this component. That will be, I think, enough. Okay, so we have it, I think. I think that's it. For each object in the scene, if the name fits, save the object. If it doesn't, find all components for each of them, add it. Okay, we can skip finding the rest of the components if it just contains one of them, right? So let's add it here, continue, and it will continue finding the next object. Awesome, so let's try it here in the tool. Well, it compiles, so let's play that. There you have the button in here, so we say hi and find. Well, it doesn't do anything, but at least I don't have any exception here, any error. But it's not working. Why? Because we are not given any output, right? We store the objects in found objects, but we don't write anything. So this is the function that finds that writes and draws all the GUI. I don't think this should be done in here. I think this should be done somewhere else in a function separated from the, drawing the UI, but well, this is a very small script. So after clicking the find button, we need to write down the things that we found. So what we should do is begin like a list. So how do you write a list? We can create a vertical zone. We don't really need it, but I think we can start doing this for the objects that we found, and let's see how it looks. So for each, oops, it's not a for, it's a for each. For each found object in found objects, we should add a line. So what's a line? We need to add a line with the name of the object, and I think we can add a button next to it to select the object in the scene. I think that's enough. So editor GUI layout, we create a horizontal layout. That means we can add several stuff in the same line. And horizontal, we need now we have the line, so inside the line we have a text and we have a button to select the object. So if that's a, I don't know if we should add a button on the left or on the right. I think on the left it looks better. So let's add this button in here. GUI layout. Remember, it's not in editor GUI layout. Button, select. That is what it's executed when we click select for this object, and then editor GUI layout. Add a text. A text is a label field. Then the text that we want to display next to the button should be the name of the object. The object is this one, found object, and the name is name. Name is already a string, so all is good. And what happens if we click select? We should make the object the active object in the scene. It's very easy. Everything related to selection on the scene is inside selection class. Selection dot active object. Oops, sorry. Active object should be which one? Found object, right? That's the only object we want to select. So that's it. Very easy button and very easy UI. Let's open this up and see how it looks. Now I'm thinking that maybe we will have some problem, because if we have a very long list, it will overflow, like get out of the window, and we won't be able to move around and see the rest of the items, because we need to add a scroll window like this one. Let's do it afterwards. So open the window. And let's see what object we have in the scene. So we have a camera with a camera component, with audio listener, and we have a directional light with a light component. Let's try to find the light component. So it's maybe light. No, don't. Maybe we can just write part of it like light, and then find. There it is. We have a directional light object, and then selecting works. This is great. So let's change the name of the directional light so we can have a similar name for both. So it's like maybe camera light. I don't know. And well, there's some problem. Is that if the L is in caps, maybe you didn't know that an L, a letter is not the same if it's caps or is not caps. So if it's a big letter, it won't be the same as the small one. And if you try to find, for example, light with a capital L, well, it's finding it. So I didn't know this worked this way. So if I put, or maybe this is not working. Let's write cam here. Cam is not finding anything, which is weird because it has main camera and camera light. Let's find it with a capital C. It works. So why did it work before? I don't really know. I know why. Because if I find light, yes, this is not finding the object by the name of the object, but from the component, right? Light has a capital L. So if I try to find transform, which is not capital T, it doesn't find anything, right? But if you use capital T, it works. So maybe we should do this agnostic to the size of the letter, or I don't know how this is called, the caps thing, the capital thing, capital letters. But it should be agnostic to this. But well, it works. So as you can see, if I say, I don't know, cam, it will find both objects. But if I try to find an object by the I don't know, audio listener, find, it will give me the camera and select the camera. This is great. This works really well, and I think this will be a very, very useful tool for everyone. I find it really interesting because when you don't remember something, it's like, how was it called? Was it like light something? And you try to find it, and then it comes up. You can find it really easy. Let's fix the scrolling thing. Otherwise, if we have a lot of, same objects, it doesn't fit here. Let's fix that. So we need to create a scrollable area here around the for each, which is editor, GUI layout, scroll area, I think. Begin scroll view. It's been a long time since I don't use this thing. So it requires a scroll position. We can see the several options we have. It's a scroll position. We can have with two booleans, which is always show horizontal, always show vertical. This is similar to Qt. I've worked with Qt many years, and this is we need to give it an initial position, which can be 0, 0. Since we don't care really this. We can do vector 2, 0. And then we can give it show horizontal to false, because we don't want to show the horizontal scroll bar. and then true to vertical. We always want to show the vertical scroll bar. Doesn't really matter, but well. And then the scroll area finishes after the for each. Editor, GUI layout, and scroll view. This is the same as begin horizontal and end horizontal. So this area will be filled by these items. I don't really know if the items inside should be a specific type in the scroll view. Let's see if that works. So let's close the window. Oh, see, we have a... I told it not to show the horizontal one, but it doesn't really listen to me, right? Here. Well, it doesn't really matter. So let's create maybe many lights. Let's copy this one many times. So we have a lot of light components. Let's change the name. I'm gonna put a different name so I check that it works correctly. Light. Let's write it wrong. Light. Okay, and then open the tool and then try to find light. Wow, it works great. It doesn't allow me to grab the scroll thing. I don't know why, but the buttons work. Or they don't work. Why? I don't know. Doesn't really, like, this works at least. Oh, by the way, you can see that when you find objects in the scene, it doesn't really give you the same order, but it finds the items in the other way around, right? From the end to the beginning. Okay, let's try to find out why this doesn't work. Okay, so I had to do a little research in here. I found that, well, if you find the begin scroll view function in the documentation that we used, this is what we used to open the scroll view. If you do this, it tells you very clearly that it returns, when you call this, it will return the modified scroll position, which is a vector 2. Remember when we created the scroll that we had to pass a vector 2 0? Well, we shouldn't do that. Otherwise, it always stays in 0. So it returns the position of the scroll during this on GUI painted step, right? So we don't use vector 2 0. We need to use a scroll position variable, which is a vector 2, that we need to create up here the same way we did with the text. Scroll position is starts with vector 2 0. We start with it in 0, and then when we do this, it returns a position. So we fit it and we get it when it changes on this drawing step. So you fit it, it changes, it returns the new one, and it's stored in the class. The same way the text is done. So this way, I suppose it will make it work. So let's try to see if it works. Light. Find. There you have it. There it is. It works now. I don't know why it keeps showing the horizontal one when there's no item, but well, it doesn't look bad. So there you have it. And the mouse wheel works too. So we can put this tool in here, like a useful tool we can use when we need to find a component. This is awesome. I think it's really useful. Don't you think? Okay, so there it is, the script. I'll give you a link in the description so you can download this script and modify it, or just use it in your project. I think it's really, really useful. And if you want to find more tutorials, I will be doing some experiments with all this in my YouTube channel. See you next time. Bye.